Hello and welcome back to another Craig and Dave Unscripted. As we promised last week, we're going to be taking a look today at the second edition of our algorithms book, which we've now titled Essential Algorithms and Data Structures. And we'll probably get into why that's so important. We've actually changed the title slightly in a minute. So I'm going to hand over to Dave pretty swiftly. This started off as a little nip and tuck exercise. I remember creating the remastered videos for OCR A-level, and when I got to the algorithm data structure section, using our book as a primary source, so there was obviously some strong links there, and I kept finding the odd little gremlin and this would be nice, and it was a little sort of list of nip and tucks, and I thought, Dave will run through those and it will be an afternoon's work. Now, this is everyone who knows Dave. This turned into a mammoth project, and what we have now is not a little nip and tuck exercise. This is a substantially revised and updated book. And without further ado, then, Dave, so what's in the second edition? Why is this more than just a quick little sort of nip and tuck exercise?
Yeah, well, as you say, I did start out with just wanting to change a few words, and in the end, I almost rewrote every word. But yeah, that's kind of what happens. So what's new? Okay, so I was keen to separate lists and linked lists. So in the first edition, I talked about lists and linked lists as being the same thing. They're not really. So I decided to separate those out and treat them as completely separate data structures. I wanted a greater emphasis on the data structures because the algorithms are all very well, but they only function on data structures. So I wanted to sort of big that up quite a lot. And look at how the data structures are stored in memory. So, how is it that a list, for example, is allowed to be indexed if it's stored as a linked list? That kind of doesn't make sense. So I wanted to address that head on and talk about how some of those data structures are stored in memory. I wanted to improve the descriptions of the quick sorts. Quick sorts is often an area that it causes a lot of confusion because there are hundreds of quick sort algorithms and 3 seem to have become very popular, whether that's the Harari method or the Lamoto method or others, and it causes a lot of confusion depending on which algorithm a teacher decides to teach in the classroom and then what algorithm can be seen in mark schemes. So I wanted to make sure that that was unambiguous, very straightforward with the source code. I wanted to make sure all the Python code was PEP8 standard, so that if you copy and paste the algorithms into an IDE that is using PEP8 standards, it's not going to give you hundreds of error messages. So I've done that. I also wanted to introduce records, objects, and trees, not just binary trees, more explicitly to make sure that it was more comprehensive. I wanted to make sure that I included adjacency matrix and lists, and although those were in the first edition, they weren't very obvious. And if you're an AQA student, you really needed more exemplars. You needed it to be more obvious. So I've beefed that up. I wanted a better match with exam questions in terms of the representation of the data structures, particularly there with the adjacency matrix and lists. And of course, as I was moving all the content around, I realized that the page count was getting a bit too big. So what I've done is I've actually stripped the VB code out of the book. So in the book, you've only now got the Python code, but don't worry, the Visual Basic and indeed C# is downloadable. And we'll come on to that a little bit later in this episode. But the result of increasing the content meant that I either increased the page count significantly, which would put the price up, or I cut out some of the code and have more room for content. And that's what we decided to do. And as a result of that, it created gaps kind of on pages. And, as a sort of publisher, you've got decisions to make about what you do with the gaps, and so I wanted to use the gaps to introduce more interesting tidbits. If you've got the first edition, you'll know there were little did you know boxes sprinkled around where we had odd gaps, and I've done more of the same. And in researching some of those tidbits, I learned quite a lot of really interesting facts about some of these data structures and stuff. There's more of that in the book. As Craig already alluded to, a few minor anomalies and bits and pieces that needed to be resolved. I'm a little bit embarrassed to admit that there were some issues with some of the pseudocode in the original algorithms, and that happened because I wrote the pseudocode, then I wrote the Python code from the pseudocode, then the Python code didn't work quite as well as it was going to with the pseudocode, obviously, so I changed that up a little bit. Then I wrote the VB code and was trying to get similarities between the two source code models, and at that point the pseudocode doesn't bear the same resemblance to the source code I've got in actual languages. And what I didn't do is sufficiently go back and make sure that there was, coherence and continuity between all those different code models. And so that resulted in gremlins creeping into the algorithms in the first edition. And it's a bit embarrassing when you've got a book out there that is supposed to be, the Bible of data structures and algorithms, and it's got a few errors in it. So obviously we were keen to resolve those. We think we've trapped every single one in the second edition, but you know what it's like. As soon as you go to print, someone's going to discover something. So hopefully that's okay. Yeah. And we'll get onto it later, but there are 24 algorithms now in Python, Visual Basic, and C#. And I wanted to approach that with the cleanest code possible. And what I mean by that is that if you go and Google some of these algorithms, like a quicksort or a merge sort or something like that on the internet, then they're often written by professional programmers, and they include all sorts of little shortcuts and little things that you might do in the industry to create, really elegant code, particularly with object-oriented approaches. There are sort of constructor methods and all sorts of things that you might use. And I wanted to sort of strip a lot of that out, because what's important for A-level students is that you've just got the code that you need and the code that you're going to recognize. So I'm hoping that you're not going to look at our code and say, what's that lambda thing? Because we've completely avoided all of the stuff that might be really complicated, or certainly is not on the specification, even if it's not complicated. We've gone for the simplest, cleanest possible code, whilst adhering to certain standards that, would be considered good practice. So there we go. That's a summary of the updates.
Marvellous. Have you got a copy of the book to hand there, Dave? You can wave in front of the camera.
Put me on the spot. I do. It's in my drawer. There we go. So essential algorithms and data structures. There it is.
Yeah.
Craig and Dave on the back.
Nice.
And what we're going to do now, I think, is actually have a look inside on a PDF version, Craig. Is that right?
We are. I just wanted to say something though. So that title there, so I alluded earlier, the first edition was called Essential Algorithms for Computer Science, and now we've got Essential Algorithms and Data Structures. And we know these are the two trickiest topics for many students and teachers. And I will hands up confess on the video here, it's an area I was always sort of weaker at in the spec. If I go back to when I first started, look at Dave's really impressed. If I go back to when I first started teaching A-level, I probably would have seen data structures and algorithms as two very separate topics. They appear separately in the spec, and in fact they appear quite far apart. Data structures appears in paper 1, algorithm appears towards the end of the spec in paper 2. It's not until you really get a grip to the holistic nature of the subject that you realize you can't separate these things. There is no point having a wonderful, elegant data structure if you don't have some algorithms for traversing it, adding, inserting, deleting. There's no point in having these amazing algorithms if you don't have the data structures to operate on. So really, I think that was a big reason for changing that title. These two topics may be separate in terms of where they appear in the spec, but a holistic understanding is essential for your students. So I think I just really wanted to sort of highlight that a little bit. So,
I think that's really important. And it's something that we've both been on a learning journey with, if I'm honest, Craig, because when I set out to write the book, I thought I understood all the algorithms and all the data structures. And for me, it was a bit of a strength, actually. It was, I'm a programmer by trade, and it was something that I was, very comfortable with. Hence why I've written the majority of the content of the book, and you've done more of a sort of QA and questioning sort of role. But I increasingly uncovered things that I just took for granted. Like, for example, with a binary tree, you just assume that, the big O is going to be ON log N. But that is dependent on how the binary tree is structured and whether it's balanced or not. And if it's an unbalanced tree, then you might not get, ON log N. And so I had to do a lot of sort of soul searching, in a sense, when I was writing the book, and think about, all of those situations that may or may not occur. That means that what you're taught isn't necessarily in all situations the truth. And another admission here, we set out to write a book that would be interesting for GCSE, but beyond the specification in most cases, and very much exactly pitched at A level. If you know Craig and Dave, you know that really our philosophy is to not go beyond the specification. It's to make sure that what you know is what you need to know, and we're pin sharp, and we just reinforce the concepts you need again and again and again, so you can ace those exams, rather than having a very broad knowledge and understanding a lot about the subject, but then having a lot of grey areas and confusion when it comes to exams. Well, I set out with that ambition, and then I completely broke my own rules because the second edition, it's fascinating, these algorithms and data structures, the more you read about them. And so I just felt, I've got to include a bit of this, and I've got to include a bit of that, and then a bit of this and a bit of that. And it's just it sort of ran away from me a little bit. And so what you've got now is a book that is really suitable for undergraduate study as well, but it's pitched in its writing style at A level. So, you're not going to get lost as a student reading that. But what I'm trying to say is it's suitable for everyone. We wrote it for GCSE and A level particularly, but it's really suitable for everyone because it contains all sorts of little extra bits and pieces. Like, for example, if you want to delete a node from a binary tree, how do you do that? You might get taught the Hibbard algorithm, or you might get taught that you can just mark the nodes as deleted using a Boolean field, and then worry about that later when you want to, balance the tree again and do things like that. So we haven't hidden away from all those situations, because inevitably you look at a mark scheme in an exam, it's got a particular approach. You think that's the only approach. You think everything else is wrong, and you think examiners aren't aware of other approaches, and they are, but they have to make the mark schemes simplistic. So, I haven't shied away from any of that, and the result is it's really comprehensive, Craig.
Stop talking. Without further ado, let's show the book. So, right, I'm just going to get rid of that banner. So I just brought up the specification mapping to start with, just to show you here. This really is cross exam boards. We've got a selection of the major exam boards here for GCSE and A level and other level 3 courses. And we've just listed down there all the various data structures and algorithms, which ones appear in the relevant boards and levels of study. So you've got a mapping there. So, this is really suitable for any course you may be studying at GCSE and A level. If I just whiz down to the contents, then we start off with a little sort of an introduction about the abstractions of memory. I'm not sure how much this Dave wants to talk about. This could be a 9-hour video. So, but then we've got the data structures first, followed by the searching algorithms, sorting, and then finally those kind of pathfinding optimization style algorithms. And one thing we have done, and this was a key point that I wanted, if you remember, Dave, right from the very first conception of the book, is we have stuck to the overall structure of each chapter. So if I just skip to arrays, we start off with and all of the chapters follow this approach. So we start off with an introduction to what that data structure or algorithm is in simple, plain, descriptive English, appropriate for the level of study. We always then have a heading that says, well, what are the applications of this? We get this a lot on forums. Well, but why would I use this algorithm? Why would I use it? And, so often we use these things because we're told to learn them without actually understanding what are the applications of that data structure. When in the real world would I use that algorithm? So we explicitly mention that. We always have some kind of visualization. We list operations that can be carried out as a data structure. And we also always make reference to big O notation and the efficiency of the algorithm. Now, we're looking at a data structure here. If we were looking at an algorithm, there would also be structured English, pseudocode, and as Dave said, actual real code in Python, although we support all three languages. So we've tried to stay very strict to that structure all the way through. So you can really, you can dive in to any. We wouldn't expect you to read this like a novel. We should go, right, I'm struggling with linked lists today, or the merge sort algorithm. And you jump to that chapter, and that chapter has everything you need, starting off with a nice, simple, descriptive introduction as to what it is. And we've tried to keep, I think, that simplicity and clarity within the chapters. Is that fair to say?
Yeah, that's very fair to say. The consistent approach to each chapter and the clarity. So although it is in depth, it's an easy read.
So if you want to have a look, talk about some of this, Dave, is there a particular sort of chapter that's a good example you'd like to sort of take us through, or?
Well, since I mentioned quick sorts, should we have a quick look at quick sorts? Because they often cause a bit of confusion. So the whole chapter starts with, an explanation of the quick sort, and crucially, what is the feature of the algorithm that makes it a quick sort? If there are so many different approaches to a quick sort, what should I be looking for to identify that what I'm seeing in this exam is actually a quick sort? Or if I'm asked to write an algorithm, what are the key features that I must remember to include in the pseudocode that I'm writing? So here, it's all about having a pivot. So all quicksort algorithms use a pivot. It just depends where the pivot is, And so we sort of talk about the features there of that particular algorithm. And later on, it goes into some depth about why choosing the pivot is important and how you can optimize the quicksort by choosing different pivots, which is, again, it goes beyond the specification, but it's interesting to understand the implications of choosing a particular number as your pivot in the quicksort. So that's the first part of that. And if we scroll down, as Craig says, we've then got sort of applications of the quicksort. So where would you use the quicksort? Now, again, you might think that, well, if the quicksort is, let's say one of the most efficient algorithms for sorting, why wouldn't I always use a quicksort? Well, there's reasons, and I won't go into all of them now, but they're explained in the book. I mean, it depends on your implementation. You could be taking an iterative or a recursive approach. I mean, typically with a quicksort, we take a recursive approach. Well, that has high demands on the memory. And if you've got a very small data set and you're trying to apply a quicksort to it, it's actually not very efficient. You'd be better off, even in some cases, you're better off with a bubble sort, believe it or not. A bubble sort can outperform a quicksort if the data set is in a very particular state. And again, I'm not going to go into all that now. It's all in the book. But it's interesting that, everyone assumes, well, I say everyone, not everyone, but students often assume, because of the way they're taught, oh, quicksort is more efficient than a bubble sort. No, it's not necessarily. And so we make sure that we cover the depth here. So as we go down here, we've got the Harari scheme, which is typically what they teach in maths. Laid out, and then we've got one of these little did you know boxes, which is additional information, a bit of a tidbit there. What's that one about, Craig? I can't really see it very clearly.
Well, just before I mention that, I was going to say this is one thing I mentioned earlier, that we always, when we do an algorithm, not a data structure necessarily, when we do an algorithm, we always start with this simple structured English. Now, it's worth noting, simple structured English is often not sufficient for the level of depth you require for an A level. It often says don't accept structured English, but it's certainly a good point to start with the fundamentals of understanding the algorithm, as opposed to dumping into sort of some proper, sort of pseudocode or language. So we always start with that, don't we? And we build on that as you move through the chapter. Oh, these did you know boxes. Dave loved these. Every time I got a blank, I would read them during my QA process and message Dave and go, you what now? Many sources present the quicksort using only one of the popular. Many sources present the quicksort using only one of the popular algorithms. This can be confusing when you compare the examination mark schemes. Indeed, in 2009, Here you go. Throwing in these people. I can't even pronounce that. Vladimir Vart something proposed a new implementation of the quicksort that used 2 pivots instead of 1. This is why I'm messaging Dave going, did he? Really, Dave? Brilliant. Excellent. Am I going to need that for the exam? No, but I had a space to fill.
Yeah, but here's the interesting little bit. So my eyes are focused on your screen a little bit more now. And it says, at the time, Java was using a variant of the quicksort created by John Bentley and Doug McElroy in the 1990s, I think that says.
Yeah.
And of course, what happened is after extensive performance tests, this new algorithm that was proposed proved beyond doubt that it was superior. And so the default method in Java now to do a sort is using this new 2-pivot approach rather than the single pivot. Now, as Craig says, you don't need to know any of that for your exam, obviously. But it's interesting, isn't it, that, you don't give any thought when you say .sort in Python. What's it actually doing? Now, I could talk about that, but it's in the book and it's not the same as Java.
I can't remember, and I won't try and find it, but I remember reading one of these did you know bits, and it was again about a new implementation to a particular algorithm. And it was something on the lines of someone had come along and said, I've got a better way of doing this algorithm. I don't think you do. And they literally put it to a competition. And he was like, yeah, mine's better. Oh, all right.
That actually was the quicksort. So what
that
happened,
was okay.
Yeah. Sorry. So Tony Harari basically challenged his boss, if I remember the story correctly. The story is in the book. And his boss, I think, was Douglas Shell, who invented the shell sort, and basically said, no, the shell sort is superior to the quicksort. And he bet him a 6pence. And Tony Harari actually proved beyond doubt that the quicksort was better than the shell sort, and he won his 6pence. So I think that's the story, but it's in the book.
Right. So as I said, we then move on to a visualization. Obviously, visualizations are a bit tricky in the book, but because we can't animate the book, but we have obviously tried to make them as clear and concise as possible. And just a quick reference, I know we're going to get onto that in terms of animating. You probably have noticed, and if you've got the first book, you'll know the start of each chapter has a QR code, and we'll get onto that in a minute. But we obviously have a lot more rich multimedia style content to support the book available. But yes, we always try and present a nice clear visualization explaining the data structure or the algorithm. We then do a stepped through example as well, and we've made sure in part of this process to make sure that these step through examples don't conflict and confuse what we present in our remastered A-level videos as well. So we've got some synergy there. And then out comes the old pseudocode. Do you want to mention anything about the pseudocode? Because obviously there isn't a standard for pseudocode. By its very essence, it's not real code. A constant form of debate on the forums, it seems. But you've adopted some standards here. Were they just sensible, common sense Dave standards? Or
I think it's a sensible, common sense Dave standard that is kind of, it's recognizable if you're following the OCR sort of reference language and the AQA language. I mean, it's always a challenge when you're creating a book for 3 examples and can be used beyond those 3 examples. What standard do you use? And I didn't use the OCR reference language, but I didn't use the AQA standard either. I used a standard that I thought was very recognizable and very clear in its intention. I suppose it looks a bit like a hybrid between all those standards, but it's what you'd expect in the industry.
It's pseudocode, isn't it? It's clear and it outlines what the algorithm should do without worrying about the nuances and syntax of a given language. That's what pseudocode is meant to do. Yeah, absolutely. And then, of course, as Dave said, boom, actual, real, compilable, runnable Python code. Well done, Dave. And although it's only presented in the book in Python, as we've alluded to, we'll show you in a bit where you can download the Python code plus the VB code plus the C# code. Actually written out there in Python. Another did you know box. Excellent. And then, of course, you dive into a different representation because, as you mentioned, the quicksort is one of those algorithms of which there are several conflicting is not the right word, but several different approaches to it, all equally valid in their own right.
Absolutely. And they're kind of known as schemes. And you get this with algorithms. We don't really teach this on the course,
No.
but algorithms evolve like all aspects of computer science. They're not static. And people are always looking for optimizations or slightly different approaches depending on the data set the algorithms are going to be applied to. And so, these things evolve, and they evolve in different directions all at the same time. So they're often known as schemes or schemas, and the Lomoto scheme is just a variation of Harari's method, basically. You could go into detail, but there are differences between the two algorithms. But in a sense, the Harari method's taking the leftmost item as the pivot, and the Lomoto method's taking the rightmost item as the pivot. And then how they sort of compare items is then slightly different. But it's still recognizable as a quicksort because it has a pivot, which it compares other items to. So we go into that now. I don't teach either of these methods, actually, Craig. And this is where the confusion comes in, because, it does depend on your teacher's experience. If they have a background in maths and they've done a maths degree or computer science degree with a heavy maths component, they may well teach the Harari method, and there's nothing wrong with that. Equally, they might teach the Lomoto method, and there's nothing wrong with that either. I don't teach either of those methods. We'll come on to what I teach in a minute, but I've made sure to include the most probable algorithms that you'll be taught in the book, in a way that takes away the confusion if you're taught one way and then you read something else, or you look at a mark scheme and you see another way. And that's what our book is really intending to do here. It's to give you that clarity that you might not have if your teacher only teaches you one method. And I'm not going to teach 3 methods in my classroom because it will confuse my students. I have a preferred method, which happens to be based on the OCR mark schemes of old. I have a preferred method I use because I don't want to confuse my students, but equally, I don't want them doing background reading and looking at, other papers from other publishers and realizing this doesn't match. And actually, there has been a situation with the NCCE materials. So Isaac Computing platform, which, Craig and I do, we don't just support, we think it's a really valuable resource, but it assumes a particular teaching method for the quicksort algorithms sometimes, and we just tried to make that a bit clearer.
There's that did you know box about winning the sixpence. I knew it was in there somewhere. So again, we've got a visualization, step through, example, pseudocode, actual code.
And this is the one I teach, this sort of Lomoto variant. Again, we won't go into the details of it, but it was made famous by a sort of Hungarian folk dance, and that's the one that appeared in OCR mark schemes. I'm not sure why. I don't know the history or background, but I like it. It's not as efficient as the other methods, but it's easy to explain. Well, I think it is, and so that's the one I teach.
As I said, a proper mention here to sort of big O notation, time complexity, space complexity, and indeed a discussion of it as well, because quite often we see these tables, but they're not. It's not then explained sort of why we jump from a particular complexity to a worst one or whatever, and so you do discuss that. And I just noticed here why there's so many sorting algorithms. There is some chapters have this extra bit at the end sometimes. And this is a key chapter where it was needed. Like, oh my, you presented me with 3 versions of quicksort. Which one am I meant to learn? So you really have gone to town here. And there's another thing I forgot. Yes, at the end of each of sort of the major sections of the book, where we have all the searching and the sorting algorithms, we sort of do a compare and a nice little sort of summary table there. At the very, very minimum high level, or what should I be remembering? And we kind of summarize those, and they appear throughout the book as well. So there's an awful lot in here. Now,
based.
Cool.
Sorry, Craig, before you go on, those
Yeah,
I just want to outline that those are based on mark schemes as well. So
yeah,
in writing the summary table, I did summarize the chapter in easy, digestible, quick sentences, and it does take some liberties as well. So where I said a bubble
sure.
sort is slow and an insertion sort is slow, and a merge sort is quick and a quick sort is quick. I mean, yes, and you can discuss that in answering questions about the quick sort. But of course, it does make some assumptions about the data structure. But the purpose of this is it's a summary table. But I went through the mark schemes and I pulled out the descriptions of these algorithms, and I included those in the summary table here. So, for example, the quicksort
Sorry, Dave.
can, it can be an in-place algorithm depending on the implementation. And little things like that I've just sort of pulled out by looking through all the mark schemes and everything.
Brilliant. So as the book carries on, we go through the proper pathfinding algorithms. There's an awful lot in here. It's a very impressive piece of work. And the other thing which this book does have, by the way, that the previous one doesn't, right at the end here, is we have an index as well, which we haven't had before. So a little extra for you. Now, I definitely, because we're already at 30 minutes, there's a few key things we definitely want to highlight. Let's just, we mentioned the... Well, there we mentioned the QR codes that appear at the start of every single chapter of the book. If I unshare this, I believe you have the web page they link to there, Dave. So we created.
I do. So let's put the banner up as well.
Oh yeah, sorry.
Got it. There it is.
There.
Yeah. So free videos and source code to download at craiganddave.org/algorithms. So you don't have to buy the book to get access to this. Okay.
No.
Everyone's got access to this, but it does supplement the book. Okay. So what you've got here on this page is a link to the download file, which I'll click on in a moment and just show you what you've got there. But you've also got some videos on designing and writing algorithms, a video for every single one of the data structures, the searching algorithms, the sorting algorithms, optimization algorithms, and algorithm efficiency. And as Craig suggests, one of the problems with the book is it's very flat, it's very two-dimensional. And the videos, will step you through these algorithms step by step. Visually, so those are very good to supplement the book. Did you want to say anything about the videos before I click on the download?
No, not at all. Other than when you go into each of those, there are videos for each exam board. So you could, if there's any little nuances in the way the exam board want you to understand them.
Sure.
So yes, you just click on any one of those.
Yeah. So if I click on the hash table search, for example, there we go.
There you are. So only appear in those two sort of A level. Something like the linear search, you'd also see GCSE there and the particular level of depth you need for the various exam boards. So you can really sort of fine tune. That was it. Yeah.
Yeah, absolutely. Yeah. Hash tables are an interesting one because dictionaries are in the AQA specification and they're not in the OCR specification, which might lead you to think, oh, you don't need to know about dictionaries for OCR then. Well, dictionaries are implemented using hash tables, and you have to know hash tables for both of those specifications. So in actual fact, you are learning about dictionaries on OCR, but you call them hash tables, and you don't tend to talk about the key value pairs that you would on AQA. So that's an example of some stuff that it's like, oh, it all depends on the implementation. Okay, can I implement a dictionary using a linked list? Well, you could, but I'm not sure why you would, all sorts of things like that. Anyway, let's click on the download zip file because this is the bit that I'm really proud of because it took me ages to do this. So what you've got literally are 24 algorithms there. So we've just been looking at the quick sort. I've got code here for you for the Harari method, for the Lamoto method, for the variant that I teach. It's all there in Python.
And in all three languages.
Yeah, I was going to say Python PEP8 standard, but also Visual Basic and C#. So if you're teaching A-level C# using our time resources like we do, then you have got all these algorithms in C# as well. And that I had to learn a little bit more C# in order to implement some of these, but again, it was about me trying to find the simplest approach, really, without introducing loads of extra stuff, so that the code sometimes is a little bit longer than perhaps it needed to be if I was using some of these little tricks and shortcuts in the language. But I wanted to try and get as much consistency across the models as I could. So if you look at the Python code and you compare it to the C# code, it doesn't look completely different. You can definitely follow the similarities between the coding methods. Obviously, some languages allow you to do string manipulation in a particular way, and other languages don't. So there are some little gotchas and differences in there. But 24 algorithms, you can download them completely free. You don't need the book for this.
However, on that note, where can I get the book? Because obviously you all want a copy. Well, first of all, some good news. If you are a Craig and Dave subscriber to our premium resources, then a PDF version is included completely for free, and it's already there. So you can log on to your premium area, just jump into your course and then over to programming, and you will see the new version of the book is there in PDF. It does have printing disabled. It is meant really as a reference copy. Feel free to pop it on a network drive for your students to read. An awful lot of effort's gone in. We've made the PDF free, but please, we would like to trust you not to try and hack the printing protection off and then send 30 copies down to Reaper Graphics. If you're that keen for a copy, buy a hard copy. But yeah, the PDF is completely for free and already included. If you are interested in a hard copy, then the book is available already on Amazon. Just type in the title on Amazon and you'll find it. It's $24.99. I can tell you now, Dave and I do not get $24.99 per book.
No, we don't. In fact, you know, I don't mind sharing this. We probably get about £4 actually, is what we get from that book. We can't make a living from this book, right?
No.
We could take the book off the shop completely and, you know, it wouldn't affect us at all, to be perfectly honest with you. So why is it $24.99, Craig? Come on, we've got a bit of beef here.
Do we?
Well, it's Amazon, isn't it?
Oh,
because
I see.
People say not Amazon. What are you doing going to Amazon? You know,
well,
come
first,
on, why is
it
on Amazon and why is that a problem?
37 minutes. I'm not going into all this.
Oh, come on. So the audience is interested. Well, Amazon basically takes 60%.
Yeah.
Okay,
sorry, hang on. They take 60% on top of us paying for the printing. So we pay for the printing cost first, and then they take 60% of the royalty.
Exactly, right. So that's why we get about £4 out of this at the end of the day, once you take all the expenses and everything, you know, into consideration. But the reason it's on Amazon is just because Amazon make it really, really easy for us just to upload the book in a particular format. And publish it for us and handle all the printing, logistics, delivery, refunds, returns. They just do the whole lot, you know. And so it's just ease. I know not everyone likes Amazon, but for us, it's just very, very easy to do that. So I apologize to schools that say we can't buy from Amazon. We can only get it from our, you know, our bookseller. Can you please give copies to the bookseller? We just have no mechanism for doing it. There's nothing stopping the bookseller buying them from Amazon and then passing them on to you. But, you know, you're going to get probably extra markup in doing that. But we have no way of logistically getting copies to your school. We don't have a publisher behind this. It's self-published through Amazon. So I thought that was worth saying, Craig.
No, that's true. And as with everything that we offer here at Craig and Dave, there's links to the paperback along with decent descriptions, videos, and screenshots over at shop.craiganddave.org. So yeah, there you go. The new data structures and algorithms book. Are there any sort of closing thoughts or comments you want to get off your chest about this journey you've been on, Dave? Because that's been quite a journey. You must be quite proud of yourself now. It's done and dusted.
Yeah, it took months
until version 3.
Yeah, no, I'm not doing a version 3. I'll do a version 3 if they change the specification and there are new data structures or
You
algorithms
heard it here.
included. But I'm not doing it. I'm not doing it now. It's a bit of a labour of love, and people never believe us when we say this, but it is absolutely true. We're not doing that for financial gain.
No.
It costs what it costs because Amazon charge you that amount, and as we've already said, we're giving away all the videos, we're giving away all the actual source code algorithms. We're doing it for students and teachers. And if you're a Craig and Dave member, you've got access to the PDF, so you don't need to buy the paperback at all. And we're doing it literally because we love computer science and we want to support students and teachers out there. But if anyone's watching this thinking we make money off this, they're completely wrong.
Yeah, they really are. They really are not. Right. Well, thank you guys for staying with us. So we'll see you again next week. I think in the next couple of weeks, we're going to be sort of discussing another one of our new resources that recently dropped. Got a Telium version 2. I've also got an interesting look at a bit of an indie game coming up as well, Dave, that a student sent us. So I thought
we got a fun one coming up. A fun one next week. The students have written a little game for us to play.
Oh, right. We'll see you guys next week for another Unscripted. Bye-bye.